section 3.4, we have examples 4 and 5 here. For example 4, we have that at a company, we have a sample of 400 ink cartridges that are analyzed to see if they are defective or not. In the sample, we have that 3 of them are defective, and we have if 5 ink cartridges are selected from the sample, what's the probability that exactly 1 of these cartridges is defective? So for these types of word problems, it might take a few times for you to go through and come up with how to go about solving these. So there are a lot of things going involved here. We know that there's a total of 400 ink cartridges. 3 of them are defective. We're selecting 5 ink cartridges, and we want the probability that exactly 1 is defective. So normally the easier part to get for these probability ones is the denominator first of all. So like we said, there's 400 ink cartridges. We're selecting 5 of them. There's no type of order to these or anything, so it'd be a combination with 5. So remember, C there represents you're dealing with a combination. The numerator is the part that's a little bit trickier here, since we want the probability that exactly 1 of these ink cartridges is defective. So here it tells us here that there were 3 that were defective to begin with. We know that there were 3, so we'd have 3, and we want to select 1 of those. So 3C1. Since there's 3 defectives, we want to select 1 of those in this case, since it said exactly 1 defective. And then times, because we need 1 defective and 4 non-defectives in this case, because it said that we have a total of 5 ink cartridges that we're selecting. So if 1 of them's defective, that means the other 4 are non-defective. So in this case, since there's 400 ink cartridges, we know that 3 of them are defective, so we can subtract that off. So that would mean that there's 397 that are non-defective. Abbreviate it here. So here we'd have then 397 C4. Once again, it's 4 because there's 4 more ink cartridges left once you select the one that is defective. Since it said that we want exactly 1 that is defective. So after we set that up, once again, you could go through and set this up with your factorials. So remember, with the combinations, we'd have our 3 factorial over 3 minus 1 factorial times 1 factorial for the first one. For the second one here, we'd have the 397 factorial over, and then remember you did 397 minus 4 in parentheses factorial times 4 factorial. Remember, if it's helpful, you can group these denominators all together. Remember, all of that has to be done before you divide it with the numerator. All of that is in the top part of this fraction, since we're dealing with a probability here. And then in the denominator, we'd have 400 factorial divided by 400 minus 5 factorial times 5 factorial. Once again, if your calculator does not have the factorials, you have to go through and simplify some first of all with the factorials like we did in the first part of this section, and then go through and multiply it out using what you know about factorials. And it means that you're doing that number times everything below it all the way down to 1. So here in this case, if you calculate this, in this case, looks like we get in the numerator, if you calculate them separately, which remember you can do it all together as well. You don't have to do them separately if you don't want to. Some of these are going to be quite big, especially whenever we're dealing with some of these large numbers. out here for you on the board. And then divide by, and then if you calculate in the denominator there, your calculator will come up with 8.32. Some of yours, it'll have like an E symbol and then 10. What that really means is times 10 to the 10th power. If you have that E, or sometimes you have an EE symbol, that means that you're doing times 10 to whatever power it is, whatever that number is after the E symbol. And then if you divide this out, we get approximately 0.037 here for the probability. So like I said before, some of these are a little bit longer than other ones. It's a matter of going through, reading through, picking out the information you need to get to your probability. Remember, if you're dealing with probabilities, those should always be between 0 and 1. Whereas the first half of these problems we did in section 3.4 in the video, we're dealing with just counting how many values you have. For these last two, for probabilities, the answers are between 0 and 1, since we're dealing with a probability instead of a count. So something to keep in mind with your answers as well. Make sure that they make sense dealing with whatever problem's being asked. So example 5 here, we have to find the probability of selecting 5 diamonds. So that means a flush in diamonds in a given poker hand from a standard deck of playing cards. So remember, once again, for standard deck of cards, you have 52 cards. We have 4 different suits. We have the hearts, diamonds, clubs, and spades. One of the previous videos, I also had written down what page you could find the deck of card information on. So you can always refer back there as well if you need to, in order to find where the deck of card information is. Or you can always look it up online as well. So here, if we want 5 diamonds, so we want to flush in our diamonds. Well, first of all, if we're talking about diamonds, that's one of the 4 suits. That means we have 13 cards in that suit. Since 52 divided by 4 gives you 13. So that means there's 13 values in each suit. And then here we want to select 5 of them. Once again, there's no ordering that has to be, it just has to be in the hand somewhere. So we'd have 13C5. Combination, once again, since the order doesn't matter. Divided by, and then we have 52 cards all together, and we're selecting all 5. So once again, that 13 came from doing the 52 divided by 4, since there's 4 different suits in a deck of cards. So then here, whenever we're figuring this out, for the numerator, what you should end up with here is 1,287. And in the denominator here, the denominator, you should get 2,598,960. And then whenever you divide that out, you should get approximately 0.0005. Remember, in general, we want to go to at least 3 decimal places. Some of these, where the probabilities are really small, you might have to go out further. And let me write it down here. So in the numerator, once again, that was 1,287, and the denominator was 2,598,960. You get approximately 0.0005. So in other words, a very small chance of getting a flush in diamonds there.